This is Geometry Unit 4, Lesson 8 on rigid motions. What we're going to look at is the properties that happen on certain kinds of transformations. So what I have in the diagram here are three transformations of the quadrilateral ABCD. We have a translation, remember, which is a slide. ABCD becomes A prime, B prime, C prime, D prime. A rotation around point O, so we are turning ABCD however many degrees around O. This one looks about 90 degrees possibly. And then reflection over a line K of ABCD. So ABCD ends up A prime, B prime, C prime, D prime. So let's look at some of the properties that happen and what does and does not happen when we do a transformation. So if we have in our quadrilateral ABCD, where BC is equal to 6, so the length of BC is 6, the measure of angle C is 50, and AB is parallel to CD, and M is the midpoint of side AD on each one of these transformations. Which of the following properties will be true for each transformation? So basically what we want to look at is what happens to its image after we do the transformation. So if I look at BC as 6 and I do a translation, I just slide it over here, is B prime C prime also going to be 6? Yeah, it is. We didn't change its size at all, so that's going to be yes. All right, is that going to be true for the rotation? If I turn this however many degrees A prime is BC prime still going to be 6? Yeah, it is. We didn't change its size, so that's also going to be. And a reflection, here's BC, BC prime is also going to be 6. We didn't change its size. All right, what about the angle measure? If angle C is 50, on the translation, is C prime going to be 50? Yes, it is. All right, if when we rotate, if C is 50, is C prime going to be 50? Yes, it is. And a reflection, C and C prime, they're both going to be 50. So we did not change its length of the side. We did not change its angle measure. All right, now, is D prime, B, P prime, C prime going to be the same? All right, well, if I take DPC and I translate it, are my points still going to be D prime, B prime, P prime, C prime? Yeah. If when I translate this, I did not change the order of the points, so that one's yes. For a rotation, here's DPC, here's D prime, P prime, C prime. Did I change them? Nope, they're still the same. And DPC, and I reflect it, is D prime, P, C prime, is also going to be the same. So I did not change the order of my points. Now let's look at parallelism. A prime, B prime is parallel to CD. All right, so if I start out with AB and CD here that are parallel, are they still parallel over here? Yes, they are. Okay, so if I look at AB here and DC here, and I rotate this, here's AB prime and here's CD prime, are they still parallel? Yes, they are. And over here, here's my parallel sides. Are these two sides still parallel? Here's AB prime and DPC prime. Yep, they're still parallel. All right, and then if M is the midpoint of AD, is M prime the midpoint of A prime, D prime? Yep. Here's the midpoint of AD. Here's the midpoint of AD prime. M is still the midpoint. And over here, AD and AD prime, yes it is. So we have looked at these all different properties. We have looked at length, angle measure, collinearity, parallelism, and midpoint. So let's see if we can figure out how to describe these properties. What we're looking at is what the transformations preserve. We say these transformations preserve or keep unchanged. If a segment has a certain length, its image will have the same length. That is, distance is preserved. All right, that's the length of the segment is still preserved. You still have the same size that you started with. If an angle has a certain measure, its image will have the same measure. So angle measure is also preserved. Now the third one is if points are collinear, their images will be collinear. So if we had 3 points in the same segment, they'll still be the same 3 points in the same segment of the image. So that is collinearity. All the points lie on the same line, collinearity. It's an R. Okay, and then if two lines are parallel, their images will be parallel. That's parallelism, the property of being parallel. If it starts out parallel, the image is also going to be parallel. And midpoint will also be, because if M is the midpoint of a segment, its image will be the midpoint of the image of the segment. So the midpoint will be in the same place on the new segment, its image. So if these properties are preserved, we call the kind of transformation is a rigid motion, or also called an isometry. You may hear it called that as well. A rigid motion or isometry is a transformation that preserves distance and angle measure. So those two things are very important. Now, how do you know if it preserves distance and angle measure? In other words, after a rigid motion, the image of any figure will be exactly the same size and shape as the pre-image. Now think about this for a second. If you are changing to a new image, does the size change? That would be the distance. So distance would be the size, doesn't change. And the shape, if you are changing the shape, that would change the angle measure, but this doesn't change. So if angle measure is the shape. So a rigid motion, what you start with is what you end with. So these three transformations we were just talking about, translations, rotations, and reflections, are all rigid motions because they preserve distance and angle measure. And also any composition of translations, rotations, and reflections will be rigid motions because they don't change the size and shape. If we combine a couple of these together, it's going to be a rigid motion because distance and angle measure are still preserved. We do not change the size or shape of our images. Orientation is another property that we refer to when we're dealing with rigid motions. Orientation refers to the order or direction of the vertices. We talked about this a little bit in a previous homework. Orientation is described as either clockwise or counterclockwise. It's the order of the points when you do the figure and its image. And we want to see if they are ordered the same way when we deal with them. So let's look at the orientation of each of the original triangles ABC. The translation, if we go from A to B to C, it goes like this. That is clockwise. If we look at ABC on the rotation, A, B, C, that one also goes clockwise. And then reflection, A, B, C, this one is also going clockwise. So in each of the diagrams, triangle ABC has clockwise orientation. Now, when we are dealing with orientation, we want to look at what happens when we do the image. Is the orientation going to be the same? Well, let's look at the translation. ABC we said was clockwise. A prime, B prime, C prime going like this is also clockwise. A prime, B prime, C prime here goes like this. ABC becomes A prime, B prime, C prime. It is still clockwise. But let's look at the reflection. A, B, C is clockwise. A prime, B prime, C prime actually goes counterclockwise. So orientation is not always preserved when you do these rigid motions. Now, when they are preserved, that is called a direct isometry. A direct isometry is a transformation that preserves orientation. So translations and rotations are direct isometries. What you start with is what you end with. If your points are clockwise, they'll end clockwise. If they're counterclockwise, they'll end counterclockwise. An opposite isometry is a transformation that changes orientation. So that was the reflection that we did over here. It started out clockwise, but it ended up counterclockwise because it flops the opposite way. So an opposite isometry is a transformation that changes orientation. So line reflections are opposite isometries. Actually, a glide reflection would be too, because that's a composition that includes a reflection. So that is an isometry. So if it changes the orientation, it's an opposite isometry. If it stays the same, it's a direct isometry. So translations and rotations are direct isometries, and line reflections are opposite isometries. Now, we have one transformation we haven't talked about, which was our property is similarity, a transformation that changes all distances by the same ratio. All right, so if you're changing something by the same ratio, you are making it larger or smaller. What are we doing if you're making something larger or smaller? Well, aren't you doing a dilation? So if you're multiplying to make larger or smaller, you are doing a dilation. So A dilation is a similarity. It is not a rigid motion because what you start with is not what you end with. It will change the size of the figure. So when you change the size of the figure, either larger or smaller, it is not an isometry. It does not preserve angle measure, or excuse me, size. So your dilation is a similarity. You will have a similar figure, but not the same figure. So if you have a triangle, for example, and you dilate it to make it bigger, like so, distance is not preserved, but everything else is. Angle measure and everything else is preserved, but these are similar figures, but not congruent figures. So a dilation is a similarity. Translations, rotations, reflections are rigid motions.